Hello, my name is Evelyn Ramirez. I'm in General Physics 1. My group is Group 5, and my teammates are Angel Macario, Abigail Mosier, and Clarissa Cerros. For today's lab objective, we will be using capstone to graph the acceleration of a glide while its mass is determined by a set of masses that will be used as a constant pulling force. For the procedure, we began our lab by finding the weight of the set of masses and also the weight of the glide. Then we signed into capstone, that way we can measure the glide and graph the acceleration with the masses. After making sure that the track was balanced and that the glider was the same length as the string that was connected to the set of masses, we then turned on the air compressor and had one of our team members give a little push to the glider in order to collect our data. Then we calculated the theoretical acceleration using the information that was gathered in capstone after the experiment. So for today's lab, we had to answer two questions.
For the question, is the statement friction and air resistance are neglectable in our experiment entirely or partially true? My group discussed that we think that the statement is entirely true, as we did not account for or measure for air resistance or friction with our equations. We thought we could consider a variable neglectable if the impact they have on an experiment be so small that the data is not significantly impacted, simplifying the experiment and making data collection easier.
For today's lab, we used 3 different graphs in order to find the experimental acceleration. The first graph was position versus time, the second graph was velocity versus time, and the third graph was acceleration versus time. We also used 2 different equations for today's lab. The first equation was acceleration equals final velocity minus initial velocity over final time minus initial time. The second equation is percent error equals theoretical value minus experimental value over theoretical value times 100.
Materials. For this lab, the equipment used was the Passport motion sensor, a ruler, 2 small weights that measured to 11 grams, a glide that weighed 195 grams, and a string that connected the weights to the glider. Using the capstone program, our experimental acceleration was recorded using a position versus time graph, velocity versus time graph, and an acceleration versus time graph. For this experiment, we did not use the whole length of the ruler. We only used the length of the string attached to the weight.
These are our Lab 3 results. This was the graph we created using the glider, and we have our position versus time graph on top, our velocity versus time graph in the center, and our acceleration versus time graph in the bottom. First, we have to start by finding our theoretical acceleration, which in order to find, we need to multiply the mass of the weights times gravity and divide that by the mass of the weights plus the mass of the glider. And for that, we got negative 0.52 meters per second squared. For our table 2, we used our position versus time graph, where we had to find the 4 points, 2 which have to be for initial velocity and 2 for final velocity. We calculated our positions and times for each of these points, and then found our position change for each and our time change for each. For initial velocity, we got negative 0.425 meters per second, and for our final velocity, we got negative 0.029 meters per second. And in order to find our acceleration, we need to do final velocity minus initial velocity, divided by final time minus initial time, which is negative 0.271 meters per second squared. For table 3, we used our velocity versus time graph, and we have to find 2 points, which was velocity 1 and velocity 2. We had to find the position for the velocity and also the time. And then we had to find the velocity change and our time change. And for that, we got negative 0.71 meters per second squared. For our next acceleration, we just used our acceleration versus time graph, and we got negative 0.74 meters per second squared for our acceleration. For our percent error, we had to use all 3 of our points, And in order to calculate percent error, we need to do theoretical value minus experimental value over theoretical value times 100. For acceleration 1, we got negative 47.88%. For acceleration 2, we got negative 36.54%. And for acceleration 3, we got negative 42.31%. And that is it for our results.
During the lab, we faced some difficulties because it was hard to calibrate the equipment and do the math needed for us to find the results. The formulas we had to use were new to us, and since we didn't have so much familiarity with them, it took more time to understand and apply them correctly. However, after practicing and checking our steps carefully, we were able to complete the calculations and get accurate results.